Today we're looking at the Graymark 509 3-watt amplifier. I think they listed as a 4-watt music power, and when you look at the size of the transistor, it's probably closer to about 1 watt. But Graymark made kits, and looking at the owner's manual that I was able to find online, I see here on this page that it dates from 1965. And I happened to find this kit on eBay. It's supposed to be 100% new and complete and unbuilt. And I have a project in mind for this that this might just work out perfect for. I have a Hammond speaker box with an 8-inch Lafayette speaker in it, and I want to put this amplifier inside of that speaker box to use as a powered speaker with my Tonschreiber. And I don't need a lot of power for, voice playback, sort of thing. Whatever tapes I'm going to play on this machine, 3 watts will be more than enough for what I intend to do with it. So this might be the perfect amplifier for it. However, as this kit is now 60 years old, I was born in 1966. I just turned 59, so I know this kit is 60 years old. The capacitors in here, even though they're brand new, are shot. They're not even. I'm not even going to risk trying to use them. We're gonna order new capacitors right off the bat. So today we're going to open up this kit. We're going to unbox, or I should say, unbag it, and we're going to take a look at all of the parts and see what we need to order. And then we're going to take a look at the schematic, and we're going to see what we can do to make this safe. And we're going to talk a little bit about why it's not safe. So first off, let's just unbox this, unbag it here, get the staple off of it. And it looks like it had been stapled before, and if I remember correctly, they had the picture on. I bought this off of eBay, and they had it. They had pictures of all of the contents there on eBay, if I remember correctly. So this is supposed to be brand new, and it sure looks it. You got your warranty card here. And here's our little chassis. Oh, and things are falling out, shooting all over the place at me here. What just fell out? Oh, what is this? Looks like it's some sort of, not sure what that is. It's tape of some kind. Came off of something here. But here we have our little chassis. It looks like it got beat up a little bit, got dented a little bit, not a big deal. And there is a picture that shows on the web, I'll see if I can insert it here, of what this looks like once it's all built. And here we have our Graymark sticker, volume, input, tone, and I think this is the pilot light here. So this goes on the front of our chassis. And we have an original, new old stock 50C5 output tube. And this looks like a 35W4 rectifier tube. So that looks new. And we have a new old stock 6AV6 tube. And oh, there's our tube diagram to put on the rear of the chassis. We have a power cord, and this is going to get changed. I'm not even going to use this cord because this is a non-polarized plug, and we'll talk about why this is not safe once we look at the schematic. We have a bottom panel here, some bags of parts, and what's this bag here? It looks like we've got speaker connectors, tube sockets, screws, hardware. But this is the one we need to open now. We want to take a look at what capacitors are in here. And we've got a parts list in the manual that tells us what the values are. But I want to see the actual parts so I know what to order. So let's just empty this out here and we'll take a look at the parts. So this is our audio output transformer, and I don't know, for 4 watts of music power, this looks really small. This doesn't even look like it's a 1 watt output transformer. This might be about a half watt transformer, but it is what it is. All right, we have some hookup wire. We have a large 150 ohm power resistor. We have some ceramic caps. These will still be good, likely. And we have some nice Allen Bradley type carbon comp resistors. We'll measure those and make sure those are all still good. Some kind of interesting tie wire. I think that's for tying up wires. We have a tone control. That could be dirty just from sitting for years. And this should be our volume switch with power switch. Can you hear that? So that's our on off and volume control. And here we have 3 electrolytic capacitors, 60-year-old electrolytic capacitors that are brand new, but unfortunately these suckers are going right in the trash. And what do we have here? A 0.1 600 working volt capacitor. We're going to change this to a film style. I should have those in film style. And we have a 20 microfarad 150 volt. And we have another 20 microfarad 150 volt. My concern with these are the size. You know, this is a pretty small chassis. I want to make sure I can find something that's maybe a little bit higher working voltage, something a little bit better quality that we can substitute in here. So look at that. It looks like everything is here. I'm not going to open the bag of the speaker connectors, knobs, and that kind of stuff right now, but all of the parts seem to be here. Let me put the stuff off to the side and we will take a look at the manual. Okay, let's take a look at our manual here. As this was a kit, and I think, if I remember correctly, this might have been a kit that was sold through schools like DeVry or ITT or something like that. I'm not sure. But they've got, you know, steps of how to do this. You know, they did a lot of kits like this back then. We have our list of parts. Our schematic we'll take a look at in a minute here. They give you all the symbols and that kind of thing. Remember, this was an educational kit. They talk about how to solder, chassis layout, wiring diagrams, tube pinouts, tube ideas, testing the filament circuit. It goes into some pretty good detail. This is a lot of pages for a kit this small. Testing the audio output circuit. This is interesting. Preamplifier testing. Chassis layout parts, chassis schematic here. I mean, this is a nice set of instructions here just for anybody to build a kit. There's a lot to learn here. Final test, performance test. Oh, this should be interesting. It basically says, does it amplify? Oh, but it's nice. They do give you some voltage charts here to take a look at what your filament voltage should be, what your plate current should be, that sort of a thing. Voltage drops. That's nice. They give you some troubleshooting stuff. Graymark Educational Products, Los Angeles, California. Very interesting. So let's take a look at that schematic here. So this is a 3-tube amplifier, and it follows a string filament path similar to an All-American 5 radio. Back in the grand old days of tube-based tabletop radios, manufacturers were looking for ways to, make everything as cheap as possible. And one of the ways they did that was by eliminating a power transformer. Normally you would see a power transformer right here. And the way they did that is they take the tubes and wire all of the heaters in series, but they used high filament voltage tubes. So for example, we have a 35W4 rectifier, and the 35 signals a 35 volt filament. And then you have a 50C5 output tube, and so that has a 50 volt filament, and you have a 12AV6 preamp tube with a 12 volt filament. So you wire all of those in series and you have 97 volts. Well, you add a resistor in to make up the difference, and so that way you drop, back then it would have been 115 volts across all of these. And you take the AC line and you rectify it, halfway rectify it, and filter it, and that was it. That's your power supply. The reason why these are unsafe is because with an unpolarized plug, you're connecting one side of that line to what would normally be your common ground path, and you're isolating it from the chassis ground through this capacitor right here. Well, if this capacitor should fail, it would connect one side of that power line directly to the chassis. And so you reach over to grab that chassis and you're grabbing onto something else metal, and zap, you just, fried yourself. So this is really unsafe in the way it is. And so we're going to add a power transformer here. It's basically going to be a 1-to-1 isolation transformer. 120 volts in, 120 volts out. However, it will be center tapped. And what we're going to do is we're going to ground the center tap to the chassis. We're going to add 2 diodes to pre-rectify it before our tube rectifier. And that will completely isolate this from the outside world and make this safe. We've got to make some changes to be able to do that, however. We have to ground one side of the output transformer. We're going to eliminate this cap, and we're going to add a resistor from the negative power supply here, or the basic common ground point, directly to the chassis. That will give us a slight isolation from the chassis. But in order to do that, we need to figure out how large of a transformer we need. So later on in the video, we're going to take a look at all of these tubes, and we're going to figure out how much filament current this draws. We will take a look at the stated anode current for these tubes, and we will try and size a transformer that is correct. We want to make this transformer as small as possible because we're going to have to fit it someplace onto this chassis here. And we've got room over here on this side, and so we want that transformer to be fairly small, if we can. I don't want to have to mount it externally, but we may have to do that. And so likely what I will do is build this up as it is shown here, and we will use a current meter, and we will measure how much current it actually draws under load, and we will size an isolation transformer for it. But first, we need to order some replacement caps. In fact, I wonder if I have any in my stock. Okay, well, I just took a quick look at my stock, and it doesn't appear I have any. So let's take a look at how this schematic works. Let me see if I can zoom you in here and get you a better look at the schematic here. Okay, I don't know how well you can see that, but unfortunately I can't zoom in anymore before this gets blurry. It may even be blurry now for all I know. But I've been looking into GoPro macro lenses, and I see they're not too expensive, and we're going to see if we can order them. The other thing I noticed is that I need to get some better lighting here for the bench, as it looks a little bit dark. So on our schematic here is our input jack here, and we have our signal coming in here. We have a tone control pot and a capacitor here. So basically this just shunts high frequencies to ground. So basically all the way up in the tone control would be no cut, And as you turn the tone control down, it starts to make the sound darker and starts to reduce high frequencies. Next, we have a volume control pot, and we have an isolation capacitor here. This allows audio frequencies to pass, but blocks DC from getting in or out of the tube here. Our 12AU6, the cathode is connected directly to ground. That's quite interesting. They don't put a cathode resistor here. They're connecting this straight to ground. And then we have our plate resistor here, supplies power to the tube. We have a resistor to ground here. Our audio signal comes into this tube, gets amplified. We have another DC blocking capacitor here. We're blocking this tube's plate voltage now from our output tube. We have another resistor to ground. We have an unbypassed cathode resistor here. This will be interesting to experiment to add a cathode resistor, or excuse me, a cathode capacitor here for increased gain and possibly lower distortion. So we will experiment with that. This is a pentode tube, and so our screen is connected to a capacitor and a resistor here that's connected to our power supply. And then we have our single-ended output transformer here. So our B plus from our supply is connected to this side of the transformer. The plate is connected to this side. We have our rectifier tube here. This is a half-wave rectifier. We have a dropping resistor here. We have one filter capacitor, another resistor capacitor combo, and that supplies our B plus to our amplifier. This is our string for our filaments, and then we have a neon light and a dropping resistor. Neon lights run about 90 volts, so we have to drop some voltage on here, so this will be happy. And then we have a power switch. And we're going to change where the location of this power switch. This power switch will be before the power transformer here, not after it as it's shown, or not here. We'll move this around a little bit. I'll redraw the schematic for you, and we'll show you the changes that we're going to make to it. So really pretty simple amplifier schematic. 2 amplifying components and our power supply, and that's really about it. Really simple schematic. Should be lots of fun to build. Shouldn't take too long. So let's get into it.